So this is problem one, richest body kinematics one. This is about the Ferris wheel, and so rotate counterclockwise. So rotate counterclockwise about point O. So and you can see that basically it will be a Rafa. And given at that instant the acceleration of 0.8, so what they give is the acceleration of 0.8 with 80 negative 80 I and negative 60 J feet per second square. And at this instant, what are the tangential and normal components of the acceleration of point B? So as you can see, they give the acceleration of point A and want us to determine the two components, tangential and normal components of the acceleration of point B, and also what is the velocity of point B. So also about velocity. So for this kind of problem, which is the problem in rigid body kinematics, you when you read the problem, a few questions you need to ask before you start solving the problem, and I'm going to list it here for you. The first question you need to ask is, does the problem give point or body properties? It's very important. So in this case, they give us the acceleration of point A. So it means that uh, they give us the point properties. And the next question you need to ask is, how many rigid bodies? How many in here? It's only one, the Ferris wheel. So it's good news, only one body. If the problem have two or more bodies, that going to be problem two. You need to ask yourself, where is or are the common point between the bodies? It's very important. Where is the common point between the body? Because that is the transition when you move from this body to the other. It always start with the body that given the informations. That's very important. So let's do for this problem. And you can see the first question is what is given. They give us the point properties. So with that, we when the problem give you the point properties, the next step you need to do is to find out the body properties of that rigid body, the same rigid body. Very important. And if they give us the body properties, the next step will be the point property on that body. So that is always in that case. If it point property, find out body properties. If give body properties, then find point properties. So let's apply it in here for this problem. So you can see now, you classify the motion. And before we find motion, before we solve, we need to know what type of motion, right? What type of motion? Very important. And in this case, as I already explained, that will be a Rafa. So the first step to solve this problem, the question asked is the acceleration of point B give a point A. And like I say, if it give a point, you cannot jump to another point property. You need to find out the body properties. So the first step I want to do is find out the body properties of the Ferris wheel. So step number one here is you have from point, start what is given, right? Property A that is given, right? To body property. And in this case, only one body, so you don't need to specify. Other than that, only the Ferris wheel. So with that, it's Rafa. So always remember Rafa stick. We need to draw the Rafa stick. Let's draw it in here with the information given. So a acceleration A is negative 80 I. So if we have x and y that way, then the ATI negative, so go to the 4.8, so go to the left, and this is 80 feet per second square. And then the second components, which is y components, that is negative 60, so it will going down 60 feet per second square. And because A on the Rafa body, what does that mean? You remember the acceleration of one point on the Rafa body have two components, tangential and normal. And the tangential components is perpendicular to the radius and tangent to the path. So with that here, that you can see the 60 feet per second square, here actually the tangential components of the acceleration of point A, tangential component. And the normal components is parallel to the radius. So as you can see, the 80 feet per second go to the left horizontal, parallel to the radius that we have here, parallel to the radius. And direct to the center, in this case, direct to the center. So exactly the 80 feet per second square is the normal component of acceleration. So with that, we can draw the Rafa stick for OA. Let's Rafa stick for OA. So we have O and we have A. So in this, we have AN, 80 feet per second. AN, 80 feet per second square. And then the tangential component, AT equal 80 feet per second square. And since AT going down, AT going down, then the angular acceleration had to be consistent with AAT or vice versa. So that we have the alpha angular acceleration have to be clockwise. Have to be clockwise. And the problem gives us the Ferris wheel should rotate counterclockwise about 0.0. So what does that mean? The motion is counterclockwise. When the motion counterclockwise, the angular velocity also counterclockwise. Keep that in mind. Angular velocity also counterclockwise. So this is omega. So that keep that in mind. So you have, and in this case, you have omega and alpha is body properties, and AAN and AAT is body properties. And give the body properties, then you go to find out give the point properties, go ahead to find out the body properties, which is alpha and omega. And we also have the position vector A relative to O here. You see the radius 20 feet, so you have 20 feet there. So that is the first Rafa stick. So when you have that, you can go ahead to solve the problem. So as you can see, AAN equal to 80 feet per second, and that's what is given. And we want to find out the body properties of the wheels. So in this case, you need to relate with the equation we have. If you recall, the AAN equal to omega square times the radius of A relative to O. And we already know radius of A relative to O, which is 20. So you have omega equal to square root of 80 divided by 20 feet for the ROA. So that will be equal to 2 radian per second. Radian per second. So that is the first body property we find out. And then the next is the alpha, just angular acceleration as a body properties. So that we start from AT. AAT, if you recall, it equal to alpha t, right? And equal to, go ahead to change that one here, 60. That's what is given over there, 60. So AAT equal to 60 feet per second square, and this equal to alpha r, a relative to O, and from that you can have alpha equal to 60 divided by 20, so it will be 3 radian per second square. So that, as you can see, they give us the point properties. You have to find out the body property. Even the question don't ask. They ask the another point property, which is point B. But we need to find out the body property first. So after you have the body property, the next step it will be point properties. So it's always body, point, body, point. Or if they give you point, then point, body, point, body. Keep that in mind. So step number 2, from body property to point, and in this case, point B, which is the question asked, property.